Section 6.10. The variation of K sub P with temperature. How does the equilibrium constant depend on temperature? The Le Chatelier principle tells us the answer depends on the sign of the enthalpy of the reaction. For endothermic reactions, K sub P increases as temperature increases. For exothermic reactions, K sub P decreases when temperature increases. Let's look at the derivation. First, the standard Gibbs energy of the reaction is equal to negative RT times ln Kp. And then we proved this equation before. As long as this enthalpy of reaction is approximately a constant between T1 and T2, this equation holds. And usually this enthalpy of the reaction is approximately a constant because the integral of delta CPM between T1 and T2 is usually very small. And therefore, we can use this equation. We can replace this delta G of R in the standard state with negative RT ln Kp. We'll just put this negative ln Kp in here. T and T cancel. Then we have negative R ln Kp at temperature 2 minus negative R ln Kp at temperature 1. On the right-hand side, we get the same expression as before. And now, both sides of this equation divided by negative R. So we have negative R here. And now you can tell that K sub P does depend on temperature. First, if we know Kp at temperature 1, we can calculate Kp at temperature 2. And 2, we can do more analysis. If T2 is greater than T1, this is negative. With one more negative sign, it becomes positive. Now for endothermic reaction, this is positive, minus, plus, minus, the result is plus. And then Kp is greater than Kp at temperature 2 is greater than Kp at temperature 1. So again, if T2 is greater than T1, and also this is positive, then Kp2 is greater than Kp1. What if the enthalpy of reaction is negative? What if we have exothermic reaction? When this is negative, we have negative delta H of R over R, so this part is positive. And then if T2 is greater than T1, then the reciprocal of T2 is smaller than the reciprocal of T1. Then this part is negative. This part is thus negative for exothermic reactions, and then Kp2 is smaller than Kp1. So we reached the same conclusion as Le Chatelier. For endothermic reactions, higher temperature results in larger Kp. For exothermic reactions, lower temperature results in larger Kp. If we know the Kp at the room temperature, we can calculate Kp at a different temperature using this equation. Why? Because we simply replace this T1 with the room temperature and this Kp with the Kp at the room temperature. And usually this is available to us. If not, we can just look up the Gibbs energy of formation of the products and reactants. And then we calculate the Gibbs energy of reaction under the standard state. And then we can use this nice simple equation to compute this K sub P at the room temperature. And then we plug it in here. Also, we can see this relation. The logarithm of Kp is linear with 1 over T. It's not linear with T. It's linear with 1 over T. And there's a slope. The slope is negative delta H over R. So again, if you plot ln K sub P, the logarithm of K sub P, versus 1 over T, you will be able to get a straight line with a slope of negative delta H over R. Now finally, I want to emphasize this. This delta H of R is approximately a constant within a small temperature range or even a moderate temperature range. So if you look at this temperature change from 300 K all the way to 1000 K, so the temperature change is from 300 to 1000, and look at this line. The enthalpy of reaction is about the same. The reason is delta CPM is very small. The integral of delta CPM from 300K to 1000K is still very small. And similarly, when we are looking at the entropy of the reaction, well, the entropy of the reaction at 1000K minus that at 300K is the integral of delta CPM dt over T. Again, because delta CPM is small, this entropy of reaction is, again, roughly a constant between 300K to 1000K. So it does change from negative 200 to maybe negative 220, 230, but still the change is fairly small considering the really wide temperature range. However, you can tell this this negative delta G over T, this changes. This negative delta H over T changes.